Okay, this is starting to get interesting. Yes, I've gone and got myself another meter. Now I've got the camera in fairly close because I've been having trouble with the focus on it, and I have worked out why that is. During the day there is no problem with the focus. During night is when I've been having the problems. It turns out it is the fluorescent lighting I'm using that is not allowing the camera to focus properly, so I'm going to have to get myself some 100-watt power chewing globes and try them out. But we have to use what we've got at the moment, so this is why we're so close to the circuit. A little later on I will be moving the camera and focusing in on the scope, because I actually believe, looking at the scope, these meters are telling the truth about the current. This meter here, I have got the negative side hooked to the centre tap of the pancake coil, and then this white lead I'm going to be placing, I'll do that right now, on the positive side of the circuit itself. I've got it set to duty cycle at the moment because this is going to show us what happens to the duty cycle and these two currents when the machine is running. Okay, so we fired it up. This meter here is hooked to the positive output of the circuit, and this meter here is hooked to the negative on the battery and the negative input on the circuit. The scope probe I have hooked across this meter, which is on the negative side. The ground is hooked to the negative on the battery, and the probe is hooked to the negative input of the circuit, which is across the resistor in this meter. The resistor, as I said before, or the resistance on the milliamp scale on these meters is 1.5 ohms exactly, and I've checked each meter with each meter and they all read 1.5 ohms. And of course we got these zero loss leads, and when you hook them together on the ohms it reads 0, so they are accurate. So 1.5 ohms on these meters across the milliamp shunt. It is 1 ohm on the amp shunt if we ever need to use that, which hopefully one day we will when we scale this up. So okay, at the moment you can see we're all near exact 50-50 on the duty cycle, and this is referenced by these two reading oh so very close. We are about 50 microamps, 40 microamps in difference, 50 to 40 microamps, and we have 50.2 on the duty cycle. So that is why this one's reading slightly more, because it is slightly higher on the duty cycle, but only slightly. So what I'm going to show you now is when I turn the frequency up, and when we get to the flat out frequency I will switch this over to our hertz or frequency scale and show you exactly what frequency we're running at, and it is very high. This has a very wide range, this little circuit here. But anyway, we will turn him up. Not too far. The only problem is that this gets very touchy up towards the higher frequencies. So now we're on 49.5% duty cycle, and we are still reading higher on this side, just because the positive side of course is also hooked to the LEDs. These three here, this one here, the orange one is of course driven off the kickback from the coil, or the negative side. What I'll try and do is get that difference greater. which is somewhere here. Like I said, this is very touchy. Maybe I have to go down instead. There we go. Now, this is a bad frequency we're at the moment, as we're pulling a lot of current. Well, as far as a lot of current goes, 8 milliamps on this side, and that is 875 Hertz at the moment. So the lower frequencies aren't very good, but what I wanted to show you is that when the duty cycle changes, this is why this is flipping over, because the duty cycle is indeed changing, and when that changes enough that the LEDs don't affect it, you can see that the current draw swaps over. So now the positive is on the low side of the current draw and the negative is on the high side, because we're down to 44% duty cycle on the positive side. And if I take this lead here and plug it onto the negative side, you can see that that side is 59.9, 60%. So somehow right about there, I would say the coil's actually fighting against the circuit itself and creating some sort of split frequency, because 60.3 and 45.6 certainly doesn't equal 100%, and we are drawing the most current that this circuit will draw. So that frequency is the worst for this coil. So now that that's explained, once again we're 50-50 there, so it's 50% both sides, and you can see the current draw is within very close to 50-60 microamps, 70 microamps. But enough on that bit of it. Now we're going to go into the negative side. So we now got our negative currents. We have a 48% duty cycle on the positive side, so that would indeed indicate a higher negative than this side, which is exactly what it's doing. So 48% on the positive side would give us our 52% on this side, which means this side will be giving back more than this side, because it is negative to what it was when this is in a positive state, a positive current drawing state. So now I'm going to move the camera and we're going to focus in on the scope, because I believe these meters are actually telling the truth. And I will get you as close as I can so we can see clearly. Yeah, it looks pretty clear. Okay, now the zero line we're going to put dead in the middle. You can see the black center line as long as the little one's going up and down. Now we are set on on our volt divisions we are 0.1 of a volt, and like I said 1.5 ohms on the resistor. Time divisions are 10 microseconds for our time divisions. So getting at the same level as the camera, our 0 volt line is exact. We'll turn the scope on, and here's what we have here. So like I said, the probe is hooked on the positive side of the circuit and the ground is hooked directly to the negative on the battery. So this top one indicates our positive pulse, and you can see we have one exactly on the second line is where that pulse stops, or the voltage stops, which means we have 0.2 of a volt across that 1.5 ohm resistor. Now on the return side, or the current going in the opposite direction, you can see that it comes down about one extra line, or one division of each division. So it's 1, 2, so that would be 2.2 volts on the return side, and then it fades out just above the 0.2 volt line, or the second division, as this one drops down below second division. Now here's the interesting thing, you can see up the top here, it is very clean on the positive pulse, if you want to call it that, but on the negative pulse you can see it goes even further, very briefly, about 3.5 divisions, 0.35 volts that would be, and that is indicating the current going back in the other direction, or our voltage over time, which is current over a set resistance, voltage over resistance should I say. The cycle period is the same, so we have just over 2 divisions, and the return pulse, or the reverse voltage and current, is actually about 2.5 divisions, as you can see there. So I actually believe the meters are telling the truth. Here there is actually more current going in the opposite direction, purely because our time factor for the return pulse, or the negative current, if you want to call it that, is actually longer than that of the positive current, and down here for a very brief period of time it is a fair bit higher in voltage. So that scope shows me that those meters are reading correct. It is also the same, only the other way around when I put it on the input, as it would be. So that's what I have to show tonight on it. Oh, hang on, I was going to show the frequency of this running flat strap. So I'll put the camera back down on that meter, which is that one there, and we will switch over to frequency. At the moment we are running at 21.8 kilohertz, so a whole lot higher than what we started with, and I have put 2 of these meters together on either side of the coil, using both negatives on the centre tap, 1 meter on the positive, 1 meter on the negative side of the LEDs, and they read the exact same frequency. So 21.8 kilohertz, 21.84 is what we're running at the moment, and I don't know guys, it would seem that the scope and those meters are both telling us the same thing, so some interesting results so far. Well, that's it from me. I'll head off and get this uploaded so you can take a peek and leave us your thoughts. Thanks guys.